Okay, this problem here says Turner counted the number of words per page in his new book. So, what do you think is the least, let's see, amount of pages or words, I guess? Okay, so I'm trying to make this bigger for you to see. There. Okay, so the way it works is your first digit is 1, like because of this 1 right here. All right, so the first number actually is going to be 10 because of the 0. And then that 1 right there is used again right here, and then the next digit will be that 7, so that's 17. And that 1 again is used, and that's a 19. Then you go down for the next biggest number, you'll start with a 2, and then you look at this digit, that's a 4, so that's 24. You go back to the 2 right here, that's a 2, and then you have a 6 for 26, and then back to the 2 again, 27, another 26, and then another 26, and then you have a 27. The next one below that is a 3. It'll be the 3 will be in the tens place, and then the ones place will have a 6, and then you have a 3 again in the tens place, and then you'll have a 7. Do you get that? What's the last number, the biggest number? Like all the way down here. What's that? Uh-huh. 90. What's the number before 90? What's the number before 84? Yep, 77. That's it. So let's see. So Turner counted the number of words. Well, that's how you read some in leaf plots. Turner counted the number of words per page in his new book. Oh, the smallest number of words was 10. So there was maybe a page that had like a bunch of pictures in it, and there was only 10, maybe just a caption with only 10 words. But then you had another page, maybe it was like some crazy small print page, like I don't know, bibliography or something, and it had 98 words in it. Okay. Okay, for this one here, so a researcher recorded the number of cows on each farm in the country. So, guy's traveling around. He sees farm A, farm B, farm C, right? Keeps traveling, all these different farms, like L and M and N. And he's like, whoa, farm A, looks like farm A has 39 cows. And then he's like, whoa, farm B's got 11 cows. And farm C has, let's see, farm C has 90 cows. And there's another farm L that's got 22, another one that's got 23. Um, let's see. I made it up. And the one has all, where am I getting all those numbers from? Okay. So forget that for now. Don't worry about that. 11, O, and 68. 68 is what was on this other farm. So then you are the researcher, and your job is to make a stem and leaf plot based on your data. Okay? So you're going to go like this, and go like that, stem, leaf. All right, well, let's go ahead. We notice that we have to kind of make the stem and leaf plot work according to all our data. And it looks like the numbers that we have are kind of between like 10 and 99, right? So like if I had numbers that were like 300 like and 24, and the next one was like 467, I would do it differently. Or let's just say they were all like in the 300s or something. I would do it differently. But because it's 39, like it's all between 10 and 99, I can have the tens placed right here and the other places to follow at the other side of this line. So I'm going to go, this represents anything in the tens. So like anything that's like 10 or 11, 12, 13, 14, 15, 16, 17, 18, 19 will go in here. Anything that's in the 20s, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 will go there. Anything in the 30s will go there. Anything in the 40s will go there. Anything in the 50s will go there. 60s will go there. 70s will go there. 80s will go there. And anything in the 90s will go here. All right, so what was the first, oops, that's not a 9. All right, what was the first one in town A? How many cows? Well, here's town A, or farm A. 30, 39. So this is like, so watch. It doesn't really matter the order that you do them in. So you have to write 39. So here's my 3 for my 30, and now here's my 9 for 39. I would like to do another one. I'm going to put a 31 here for P. 31. All right, let's do P now. How many in town P or farm P? 31. Well, what comes first, 1 or 9? So I'm going to scoot this 9 over to make because the 1 comes before it numerically. So now this is 31, and this instead of going like this and just saying 31 and 39, right? And like I'm putting 1 3 here, and it's like being distributed to the other numbers. So I'll get the 1 there, and then that can go away, and that can go away. Well, it's more, it's no, it's not like an X and Y thing. It's more of just like representing place values. No, no, it's the number of place values. So watch. So now that you understand this, look. Well, do you understand how this 1 and 9 came about? Huh? All right, so I took care, let's just put it together. So, but I'll tell you what represents a farm. This is farm A right here. So that's farm A, that's farm P. Okay, so tell me about farm B. How do I input that? All right, so what should I put here? Just a 1, and there's my 11, right? All right, now what about farm C? How should I do that? hmm I understand. I'm going to answer your question in a sec. Keep going. So what about farm L? So what do I do with that? Okay. What about farm M? Okay. And farm N, oh, that was L and M. What about N? Good. Keep going. What about farm O? Okay, so an 8 next to the 6. Great. Now let me ask you, of the farms that I did in my problem, how many farms had exactly 90 cows? 2. Farm N had 90 cows, and so did farm C. 2. Do you know how to answer the question now? To answer your wait, it's like okay, so like let's say you have random numbers like 22, 18, 13, 49, 63, 84, 22. Okay. Now, what you want to do is you want to put in from actually hold on one sec. Pause. Okay, so let's say you have these numbers. Um, so 33, 42, 17, 18, 24, 38, 15, 24, 21. Over here I'll write 20. Um, then I'll write 27, then 12, then 90. Okay, put these numbers from least to greatest. 15, 17, 18, okay, 20. I see a 12 here. Right, I just right here. We'll put okay, 20. Uh-huh. 21, 24, 24, 27, 33, 38. Wait, 33. Did you say 38? Oh, yeah, 38. Uh-huh. 27, 42, and 90. All right. So then looking at these numbers, it's just like visually, does it tell you anything? That they're in order. All right. So now we're gonna do a stem and leaf plot with these numbers. Okay, so I'm gonna go like this. I'm gonna go like that. There's my stem, my leaf. And what goes first? One, and then what goes next? Two, and then comma, five, comma, seven, comma, and eight, right? All right, what goes after that? Two, zero, one, four, four, seven. Okay. And then after that, three, and then three, eight, and then over here, four, and then two, and then I have to put, yeah, yep. So five, six, seven, eight, nine, and then nine gets a zero, right? Okay. Now I'm gonna go like this. Now look at it like a histogram. Which one is the most prevalent? Two. Do the numbers tend to be closer to the tens or closer to the 90s? Uh-huh. Closer to the tens, right? Because you have the 12, 15, 17, 18s, right? Um, is there a lot of stuff happening in the 60s and 70s? Is 90 probably like kind of a weird value? Yeah. So a sum and least plot lets you visualize data. You can all that's its purpose is to kind of see things visually, kind of like a histogram. And so it's like that. That's its purpose. So you don't really add up the numbers unless they're asking you to do something like that. It's just a way of displaying numbers to see like, oh, it's it, it's a way of showing numbers in a way that's better than this. You see, when you look at it like that, it might not become apparent that there's a bunch of numbers in the 20s and in the 10s. They kind of all blend in together, especially if they're all disorganized like in the original group up here. Then you don't even know. So it's a little bit more organized this way and a lot more organized this way.